Good morning, dear students. Today we have to study the activity 6 about the coding and the treatment of the nervous information. At the end of this video, you will be able to deduce that the nervous message is coded in terms of the frequency of action potential of same amplitude, infer that the frequency of the action potential depends on the intensity and the duration of the stimulus, and conclude that the treatment of the coded nervous message occurs in the nervous centers. First, what is a stimulus? The stimulus is the factor, the cause, which causes a response of our nervous system. It triggers our nervous system to react. We have lots of examples of stimulus, like when a rabbit sees a fox, it runs away. So the cause of running away is seeing the fox. So seeing the fox is the stimulus. And in this case, the sensory organs are the eyes. Someone calls you, so you have to answer. So calling you is the stimulus, and the sensory organs are the ears, because we have to hear the call. The smell of pepper makes you sneeze. Smelling the pepper is the stimulus, and the sensory organ here is the nose. And when you touch a hot object, you remove your hand directly. So the hot object is the stimulus, and the sensory organ here is the skin. Pay attention, not the hand, the skin, because we feel the hot object by our skin, not our hand. These stimuli, the plural of stimulus, are detected by our sensory organs. Our sensory organs are 5. The eyes, when we see something, the ears, when we hear, the nose, when we smell, the tongue, when we taste, and the skin, when we feel the touch. But what is the structure in these sensory organs responsible to accomplish this role? We have something called sensory receptor. The sensory receptor is the nervous structure that detects the stimulus and it transforms it into an electric nervous message. So inside these 5 sensory organs, we have a structure called sensory receptor, which is specifically responsible to detect the stimulus and translate or transform it into a nervous message. We have many types of sensory receptors according to the type of energy of stimulation. I will give you many examples. When the stimulus is pressure or touch or stretching, the type of the receptor is called mechanoreceptors. When it's temperature variation, when we feel something hot or something cold, the receptors are called thermoreceptors. When the stimulus is the pain, the receptor is nociceptor. When it's a chemical substance, it's called chemoreceptor. When it is the light, it's called photoreceptors. So we have many types of receptors according to the stimulus. Now we have to pause the video, read the first paragraph on the book, page 74. Let's now read the paragraph. Pacinian corpuscles are sensory receptors found in the dermis of the skin and sensitive to pressure. From this paragraph, what is the name of sensory receptor? So it is Pacinian corpuscles. What is the location of this receptor? It is located in the dermis of the skin, the second part of the skin, the middle layer. What is the kind or the type of detected stimulus? It is sensitive to pressure, so it is a mechanoreceptor. We have now to apply an experiment on these corpuscles. We have to make a pressure on these corpuscles and record the results on the screen of oscilloscope. After applying a series of mechanical stimulations, pressure of different magnitudes on a nerve fiber, we measure the variation of the number of action potential as a function of increasing magnitudes of pressure during 3 seconds for each stimulation. The results are shown in document A, page 74. These are the results. The pressure in gram per centimeter squared, and the action potential here, the number of action potential. This is the manipulated variable, the variable that we change, and this is the responding or the affected variable, which indicates the result. First, the pressure was 0.2 gram per centimeter squared. It increases till 0.6, then it continues increasing to reach 16 gram per centimeter squared. As the pressure increases, the number of recorded action potential increases. We have to transform the following results in a table. So, in the table, the pressure is up and the number of action potential is down. We have to write all values of pressure and to count the number of action potential. Here we have 0 action potential. Here we have 1, 2, 3, 4, 5, 6 action potentials. Here we have 12, 17, and 27 action potentials. So it is a table that shows the variation of the number of action potential as a function of pressure, because when the pressure increases, the number of action potential increases. What's the meaning of the word frequency? The frequency in physics is the number of oscillation per 1 second. Here we are not studying something related to oscillation or electricity. We are studying action potential. Then the frequency is the number of action potential per 1 second. If each recording is obtained within 3 seconds, we have to calculate the frequency in each case. So, as a rule, as a formula, the frequency is the number of action potential divided by the unit of time, which is here 3 seconds. The number of action potential is 0 divided by 3, we have to obtain 0. The number of action potential 6, which means that we obtain 6 action potentials in 3 seconds. So how many action potential did we obtain in 1 second? We have to divide by 3 to obtain 2. Here we obtain 12 action potential in 3 seconds divided by 3, so the answer is 4. Same for 17 and 27. So now the table represents the frequency of action potential or the variation of the frequency of action potential as a function of the pressure. Now we have to interpret the obtained results. These are the results. We have only to interpret the variation of the frequency of action potential as a function of pressure. So forget the number of action potential. In the interpretation, we have to write the analysis and the significance. The analysis, when the pressure was 0.2 gram per centimeter squared, the frequency of action potential was 0. When the pressure increases to reach 16 gram per centimeter squared, the frequency of action potential increases to 9. But we have to say keeping same amplitude, because as shown in the figure, always the action potential having same amplitude. So we have to say keeping the same amplitude, since the amplitude is not increasing when the pressure increases, only the number. This indicates that the frequency of action potential depends on the intensity of stimulation. We can't say in the significance this indicates that when the pressure increases, the frequency increases, since it's the same as the analysis. Okay? Now, what can you conclude concerning the coding of the nervous message at the level of nerve fiber? When you look to this figure, we have to make the first stimulation. We obtain 2 action potentials. When the intensity increases, the number of action potential increases, and when the intensity keeps increasing, the number of action potential only increases, but always having same amplitude. So the frequency is variable, which means that the number of action potential is variable. The amplitude is always constant, so the nervous message in a nerve fiber is coded in terms of frequency of action potential, not amplitude, since the amplitude is always constant in all intensities. Now, at the end, what is the meaning of the nervous center? You know, in vertebrates, we have the central nervous system made up of the brain and the spinal cord. The brain having cerebrum, cerebellum, and the brainstem. These are the nervous centers, the centers that are responsible to give orders, to interpret, to analyze each action. They control most functions of the body and mind. They control the things that we choose to do, like walk and talk, and the things that our body does automatically, like breathing and digesting food. They treat the coded nervous messages. For the next time, you have to study the summary sheet and to solve the extra sheet.